On our work regarding the intestinal failure, we really try to design therapies that are focusing onto the patient. And there's few limitations to translating this research to the patient, which is related to the steps that we are trying to address in the research questions. So the first is that organoids are being shown to replace the mucosa and can actually replace completely the mucosa of the intestine. But however, they're expanded at the moment using matrigel type of system. So those systems cannot be used for GMP grade expansion of the organoid, so we cannot be used for human transplantation. So the idea is that if we use a more a gel derived from natural tissues, such as the deserialized intestine, that we could actually translate in a GMP. So that's why we have developed a part of our research to obtain gels that are derived from deserialized tissue. And we have shown that those gels can help expanding the organoids very similarly to what matrigel does. The other aspect is that, of course, it has been tried by us and others to engineer the entire intestine. But the intestine is a very complex organ, which not only rely on the mucosa, but there's the lymphatic system, the endothelium, the muscle, and so on. And so in some patients, particularly in children, but also in adults that have short bowel, they lose the entire small bowel, but they maintain the large bowel in situ, so it's in the patient, but of course is very little relevant to absorbance of fluid and food. So our aim is somehow just focus on replacing the mucosa of the large bowel. So the idea is that if we engineer a functional small intestinal mucosa, we could transplant that in the large bowel and make the large bowel becoming, in a way, the small bowel. And that's where the research has been focused. And similarly, Dr. Sato in Japan has been trying to replace the colonic mucosa using small bowel organoids. So that's very nice, because having other people that are trying parallel experiments in a similar way is very important, because it makes your research more robust. And this is one of the type of technology that could be seen translated into patient in a sort of a hybrid way, as I was mentioning before with the liver. Here we could have the intestine that you transplanted, which is not the entire intestine. We are too far yet to make a functional entire intestine, but we could translate it into patient as a functional mucosa, which will be very beneficial for those patients, and will overcome the problem related to parenteral nutrition and transplantation.